Okay, so hello everyone, welcoming you to our third part of our discussion of the PEA 2022 paper. And now we are going to begin with question number 4. So let us first have a look. So this is a question on cost and production. So the production function has been given to be a Leontief type, which is minimum over 2L comma K, where L and K are the amounts of labor, and the cost function, which is C of L comma K, has been given to be W times L plus R times K, the standard format. And L star and K star is the combination of labor and capital, which is the cost, which minimizes the cost subject to the constraint Y of Lk greater than equals to Y bar. So what is your L star and K star? It is the cost minimizing input values. Cost minimizing input, and it is subject to the constraint that y of L comma K has to be greater than equals to y bar. So this is the constraint that we are actually facing. Y of L comma K greater than equals to y bar. Now naturally for cost minimization, so let us first understand that so this is my constraint. So if the constraint is binding, what will happen? So for binding constraint, because you can understand one thing, that the more you increase your level of production, the higher will be your level of cost. So naturally the constraint has to be binding for cost optimization. So for binding constraint, y of L comma K is equals to y bar, right? Therefore y bar has to be equals to minimum of 2L comma K. This is what should happen. And we know that for perfectly that for Leontief type production functions, what will happen at optimal? 2L should be equals to K, and in this case should be equals to Y star. So what is my L star over here? Y bar by 2. And what is my K star over here? It is simply Y bar. As simple as that. So this basically matches with my option number C. Pretty easy question over here. Moving on to the next one. Question number 5. This is a question from Purno. Heterogeneous costs that have been mentioned. So we basically have two firms, 1 and 2, producing the same good. The inverse demand function is P of Q1 comma Q2 is equals to 1 minus Q1 minus Q2. Firm 1 produces Q1, firm 2 produces Q. What is the cost? So Ci, which is a function of Qi, is equals to Ki times Qi, where Ki belongs to 0 to half. Note that there is no fixed cost for each firm. Then the Cournot equilibrium profit for firm 2 is. So basically we need to find phi 2 star. So essentially you can understand, in order to find this, we need to first find out the equilibrium Cournot quantities, and then find out the equilibrium market price, and then comes the profit. So it will be a little lengthy, but the calculations are more or less simple when you understand them. So let us have a look at it once more. So what is the profit expression for firm 1? It will be price times Q1 minus C1. So what is P? It is 1 minus Q1 minus Q2 times Q1. And what is C1? It is K1 minus Q1. What does the firm 1 do? It tries to maximize profit by choosing Q1, considering the firm 2's output as given, right? This is the idea of the Coulomb equilibrium. So this will, if we maximize pi1 with respect to q1, what are you getting? You will be getting 1 minus 2 times q1 minus q2 minus k1 is equals to 0. So if you just swap the sides, you will be getting 2q1 plus q2 is equals to 1 minus k1. This is your equation 1. And k1 lies between 0 and half, so the right hand side is positive. Exactly in the same way, we will be writing down p2. So this will become p times q2 minus c2. So this is 1 minus q1 minus q2 times q2 minus, what is the cost function? It will be k2 times q2. So now what will form to do? It will try to maximize its output by choosing q2, taking forms 1's output as given, as a constant. So if you maximize this expression with respect to q2, you are getting 1 minus of q1 minus 2 times q2 minus k2 is equals to 0. And that implies q1 plus 2q2 is equals to 1 minus k2. This is your equation number 2. Now what we'll do, we'll solve equation 1 and 2 to get to the answer. So what is my optimal q1 star? You can use the Cramer's rule, you can use the Martin's rule, whichever one is favorable. So I'll use the Cramer's rule. So this will be 1 minus k1, 1 minus k2, 1, 2, and the determinant, so coefficient determinant will be 2, 1, 1. So this is essentially 2 times 1 minus k1 minus 1 minus k2 divided by 3. And q2 star will be equals to determinant of 2, 1, 1 minus k1, 1 minus k2, and divide by determinant of 3. So this will become 2 times 1 minus k2 minus 1 minus k1 whole divided by 3. Now essentially all these terms are positive, right? 1 minus k1, 1 minus q2. So q2 star is positive. You can just check it out if you want to. So this will become 2 minus 2 times k1 minus 1 plus k2 divided by 3. So that is 1 plus k2 minus 2 times k1 divided by 3. So k2 is a positive number and k1 lies between 0 and half. So essentially 1 plus k2 is greater than 1, and this will be adding it up. And similarly this will be 2 minus 2 times k2 minus 1 plus k1 divided by 3. So this is 1 plus k1 minus 2 times k2 divided by 3. So therefore what is p star? It is 1 minus q1 star minus q2 star. So 1 minus p1 star is 1 plus k2 minus 2k1 divided by 3 minus 1 plus k1 minus 2k2 divided by 3. That is 3 minus 1 minus k2 plus 2k1 minus 1 minus plus 2k2 whole thing divided by 3. So this is 3 minus 2, that is 1 plus 2k2 minus k2 is plus k1 plus k2 whole divided by 3. That's the thing. Therefore now we can calculate pi2 star. It is p star q2 star minus k2 q2 star. So q2 star we can easily factor it out, p star minus k2. So q2 star is basically 1 plus k1 minus 2k2 divided by 3, and this will 1 plus k1 plus k2 divided by 3 minus k2. So this is 1 plus k1 minus 2k2 divided by 3, and this is 1 plus k1 minus 2k2 whole divided by 3. So the final answer is 1 plus k1 minus 2k2 divided by 3 whole square. And in the options, this basically matches with option number D. That's the answer. Thank you.